Dzień dobry. Still my only two words in Polish. I will talk about JWT, and first of all, I have a question for you. Who already knows or work with JWT in the room? Okay. Like always, when I ask this question, a lot of hands raised. This is quite scary to speak about a subject almost everyone knows. So I will try to give you something interesting. Well, I will first of all introduce myself. I'm Karim Pinchon, backend developer. I'm from France. You can follow me on Twitter if you want. And I write a little blog post sometimes, but sadly only in French. And you can find this slide on slide.com/kpn13. I work from a company called Fox Intelligence, who build software who allow customers to analyze some e-commerce data about market shares and growth index and KPIs and so on. Our customers love us because, of course, our logiciel is really cool, and also because we have the biggest user panel about e-commerce in Europe. So it is very interesting for us. For them. I will introduce some basic concept, first of all. What is a token? This is a main subject here. A token is only a string, and it could be used for authentication or authorization, and probably for some other things. But this is the main subject. Is it really a simple string? In fact, no. We can find two different families of token, the reference token and the value token. The reference token will be just a string which will do some reference in your system, in your database, and that's all. And there is the second part, the value token, which will bear some data in it, and as you may know, JWT is a value token. JWT is defined as a compact and secure way to transfer some data. There is a lot of different implementation in a lot of programming language, so you have really a choice here. And in fact, it's rely on something called SWT, Simple Web Token, but with the JSON part, of course. Little fun fact: in the RFC, the author suggests that we could name JWT JOT. In France, we don't call it regularly like that. I don't know you, but some basic information concept about cryptography. What is cryptography? In fact, it's several mathematical methods who will bring some trust in an unsafe channel, like HTTP, for example. And this will bring some property to our exchange. At least 4 property. In fact, there is more than that, but we will be interested only by 4. So confidentiality, authentication, integrity, and non-repudiation. I will define this term just right now. The first cryptography method is the digital signature. This will bring integrity. That means that the message, we are sure that the message hasn't been modified during the transfer. Authentication, that means that we are sure for whom the message was sent. And non-repudiation, it means that the sender could not deny to have sent this message. Then we have encryption, which will bring some confidentiality on top of this. We have hash method, which is well known from developer, which will allow us to add integrity to our message. And this is only a one-way method. So by taking a message, we took a hash, so like a fingerprint. And with this hash, we cannot go back to the message. We have also the MAC and HashMAC, which is basically some hash, but with a secret in the algorithm. And this will bring some integrity and authentication. And finally, we have encoding. Encoding is not at all a cryptography method, so it brings absolutely no security, no property about safety here. This is just kind of a shift of character registry. Now, let's deep dive into what is a JWT. First of all, if you never saw JWT, you can find on this website a cool user interface to deal with JWT. And there is a website less known, but in fact more powerful, which is token.dev. Here is a very simple example of JWT, really common. This is just a string, but if we add some colors on it, we can see there is 3 parts separated by dots. And if we base64 decode this, we could find something more interesting. In fact, we have 2 JSON objects, a header and a payload. And at the end, we have a signature. Here is just a hash mark. In fact, the signature will help us to be sure that the header and the payload hasn't been modified during the transfer. So we can rely on the data inside the payload and the header. Here, something way less common is the JSON serialization format of a JWT. This is a JWT. But the first example I show you was the compact serialization format. Here is the JSON serialization format. This is way less practical to be used in an HTTP context, for example, to be sent in an HTTP header. But it has 2 benefits. The first one, we can add several signatures, which is impossible with the compact serialization format. Also, we can have a fourth property, which is the unprotected header, and you can add some data in the header, in the unprotected header, but this won't be securely verified by the signature. So, yeah. Now, let's take a little focus on the header part. So the header part, you could have a lot of property, and this will contain all the cryptographic method applied to get to have the signature of the token. So of course, all of this is not mandatory. It depends of your use case. Now let's take a little focus on the payload. The payload is the data you want to send, you want to transfer to someone. And we can find 3 different families of data here. The first one is the registered claims. This is defined by the RFC, and this is really a good start when you start to implement a JWT. You have several properties, all about the token. Who emit the token, has issued the token, for whom, what is the subject of the token, is it still valid, etc., etc. Okay? And for safety reason, we will talk about it later, it is really important to use that. The second part is the public claims, so it's not part of the RFC, but it's defined in the IANA. The IANA basically is the organization who gives some names on internet stuff. Okay, it's a very wide definition, but yeah. And especially for OpenID Connect, again, we will talk about it later, there is some specific claims you can use here. And finally, you can have what we call the private claim, so it's totally freedom. You can put whatever you want in your token, but be careful. This technology is meant to be compact, so don't put your whole, database scheme in your token. No way, Jose. So, Jose is JavaScript object signing and encryption, and it is a whole set of specification around JWT. And in fact, JWT is just a small piece of Jose. So there is an RFC specific for JSON Web Token, but it's only describe how we can exchange claims between 2 parts and nothing really more. Then we have the JSON Web Signature, which has an RFC specifically, and it defines how we can sign the token. So what we saw before, it is a JSON Web Signature. It is the first implementation of JWT. But there is, like I said, a second implementation of JWT, which is JSON Web Encryption. And now we have not just signed token, we have encrypted token. So with confidentiality on top. Because, as you say, base 64 coding is not cryptography method. So this is basically in clear text. So with encryption, we have the confidentiality, which sometimes could be useful. Also, we have an RFC for JSON Web Algorithm, which define all the algorithm you can use for either signature or encryption. And this is really important to stick to it, because for security reason. But again, I will talk about it later. And the last one I want to talk about is JSON Web Key, which is defined how we can represent and transfer the key we will use for signature and encryption. There is more, in fact, RFC and stuff around JWT, but this is a good start. Now let's take a look at a JWE, because it's way less common than a JWS. So here you can find the compact serialization format of a JWE. I put approximately the same amount of data than for the first example. And you see this is way bigger because encryption increased the data volume. So now see, I put some colors on it, and you find 5 different ports still with dots. Well, JWE is way more difficult to explain and code than a JWS, but I will try to make it simple. First of all, you need to have a symmetric encryption key. Okay, with this key and an initialization vector, which depend in fact of the encryption algorithm you choose. You will encrypt the payload, so the ciphertext. As a result, you will have the ciphertext, but you will also have an authentication tag, which is some kind of control flag to verify that the encryption has been correctly made and not corrupt, etc. But again, it depends on the encryption algorithm, so this is the most common case, I think. When you have that, you will take the encryption, the symmetric encryption key, and you will encrypt this key with the public key of the receiver. Okay, and then you will concatenate all these things with base 64 encoding, etc., and you will have your JWE. This is really the basics, but it could really depend on the algorithm you choose. Here you can find exactly like the same, like for JWS, the JSON serialization format of a JWE. And for ending this presentation of JWE, you can find probably the best PHP implementation of JWE, because it is really, really easy to find implementation of JWS in PHP, but for JWE is way more complicated, and this one is really, really good. Now let's talk about key management. Like I said, JSON Web Key will bring us some proposal to how we can represent the key. And here, it is an example of a symmetric key representation. So, for example, the algorithm you should use with this key is an etc., which is a symmetric algorithm. Sorry. And you can have the key type, so oct for octet, so simple string, and the key, the k, is our symmetric key. Now, it is a representation of a key set, because we often have to deal with more than one key. And you can represent it like that. A very important, and maybe the most important property here is the key ID. So basically the identifier of your key, which could be very interesting to put into your JWT and find the good key to verify it. Here you can find an example of an URL to a public key or X509 certificate. And here, JKU, you can find the URL to a a key set. Sorry. So there is really a lot of property. I just show you some basic one, but in fact the RSA is very wide. So, what are the usage of JWT? Well, the first thing we can thought is API is to be used as API token, and the main advantage is if a client use a JWT, send it to the server get the JWT, and will verify the signature or the encryption, etc. And we'll be able to authorize this request without being able to ask for an authorization server or I don't know why, I don't know what, to authorize or not the request. So in terms of reliability and scalability, it could be very interesting. A second usage is to use into OAuth 2. OAuth 2 is a delegation authorization protocol and no authentication protocol. In this protocol, we have something called access token. The access token will allow the bearer of this token to access to some data, resources. And this access token could be either a reference token or a JWT. And there is a specific RFC explaining that. Also, we can use JWT in OpenID Connect. OpenID Connect is a layer of authentication on top, built on top of OAuth 2. There is another token in OpenID token called the ID token, which will bear the data about the connected user. And with this token, which is a JWT, you will be able to spread the authentication of your user anywhere in your system or your microservices or I don't know what. Another usage of JWT is to use as stateless session because you know basically the session are in the server side, the user session are in the server side in a Redis, for example. But in fact, you can put all you can set in your session in the server side, but in the token. And by doing this, the token will go through the request and the response each time. And then you can rebuild the session each time by using the JWT. So again, in terms of scalability, it could be quite interesting. To be honest, I never used that. It has some part of risk. But I know this is something which could happen. And finally, in fact, JWT doesn't come with some usage. You can absolutely imagine what you want. This is only a matter of security into a transfer of data. Well, like all which touch about authentication, authorization, cryptography, this is something interesting for malicious user, of course, to be exploited. So what are the vulnerabilities? The first one is an unsecured token. You know, in the header part, I told you that this concerns all the cryptographic method used to sign the token. And in the alg property, you can find the algorithm choose to sign the token. It is perfectly possible to add none as an algorithm in the token, and so not sign the token. This is described in the RFC. Okay, so if a malicious user stole a token, just modify the alg by set none instead of any algorithm, remove the signature part, modify, of course, the payload as you want, send the token. It could happen that the token will pass the authorization, because if the server only rely on the alg, he just see, oh, non-algorithm, so I don't verify the signature, so this token is valid. And okay, so this thing has been exploited in the past, and in fact, you have to be careful if you develop yourself your JWT validator, because something like this could happen. A second vulnerabilities is kind of the same process, but more smart, I think. Imagine you have a token signed by a private key. Only the public key could verify the signature. If I am a malicious user, I stole the token. I don't know how, but I can get the public key, because the public key is more accessible than the private key. I will change the algorithm to from an asymmetric signature to a symmetric signature, and then I will modify the payload. I will sign the token with the public key with a symmetric algorithm, and then I send it to the server. The server will rely on what there is in the alg part. You will see, oh, this is a symmetric key. I will verify it with a symmetric algorithm by using the public key. And so it will authorize the token. Further vulnerabilities, well, there is no protection against brute force in JWT. So if I am a malicious user, I can steal a token and just brute force the secret until I found the key. When I found the key, I will be able to generate and forge my own token. Modify encrypted data. This one is very tricky, but it could happen. If you have a JWE, so an encrypted token, it depends of the algorithm you choose, but some algorithm does not provide integrity check. So it is possible to modify the encrypted data without having to break the encryption. So this is why you have to check the JWA, JSON Web Algorithm, to choose your algorithm. Because if I am a skilled malicious user, I may be able to just change one Boolean to 0 from 1, from 0 to 1 for, I don't know, isAdmin property, for example. So it could be interesting. Last vulnerability is the substitution. Imagine on a system, I am kind of administrator on some part and a simple user on another part. I sniff the request. I see that some token part here and some other JWT part here. If I take the token for the admin part and I set it in my request for the user part, I may have more right than I should have. And I just want to tell you about JWT paradox, because we can trust the JWT header or payload until we have verified the signature. But to verify the signature, we have to rely on the header part. So there is some kind of paradox here. Well, let's talk about some advice to avoid all these vulnerabilities. First of all, the secret. Either you use a symmetric or asymmetric key or whatever. you need to keep the secret secret, of course. You have to protect it. You have to have a real policy about it, so rotate it, etc. Don't accept everything, and in fact, don't rely at all on the header part. Never. This could be compromised, like I hope I have demonstrated you. So never trust the header part. Just have some hard-coded, I don't know, algorithm you can handle, and so on. Validate the claims, and specifically the registered claims, because you have to avoid substitution, for example. You have to be sure that the token has been made by someone you know, and this is made for you, and this is valid, and etc., etc. This is kind of, we can discuss about this point, but I would always prefer to choose asymmetric over symmetric, of course, because if you share a symmetric key, this is really less secret. So, but in fact, it depends on the situation. But I would, by default, choose asymmetric. It is really simple and really quick to develop your own JWT validator, at least for JWS. For an encrypted token, is way more complicated. But it is also very easy to let some holes in your implementation, like unknown unsecured token, for example, and so on. So rely on a well-known and library. Again, we can a lot discuss about this point, but I would advise that you don't have to fight for revocation. JWT, our technology, is a technology to be kind of autonomous. A JWT has a lifetime. If you are really in trouble for revocation, maybe you could just set a shorter lifetime. Maybe it could just be enough. Well, in the real world, we have to deal with some issue with that, like that. So I would advise two things. Maybe you can just have a deny list and check the JTI, so the JSON Web Token identifier, or you can just rotate the key, and so the token won't be it won't be possible to check it, to verify the signature, sorry. Just a simple point about privacy. Reminder, JWS, so sign token data are totally in clear text, so be careful, do not put any sensitive data like passwords and so on. Don't log JWT, as you won't log any password, so do the same with JWT. Put only require and sufficient data. It is tempting to add a lot of data about the user or I don't know what in the JWT to maybe have some to be sure that we will have the data we want. But I think we should have a more incremental, operation for this and keep the token again the more compact possible. Now we will see. We have seen that there is some kind of issue with JWT or with implementation of JWT. In fact, so we can think there could be something better. So let's see what we can have. Maybe you heard about Google macaroons. So it's like a token. It's kind of token. We can go in a microservice architecture. So it's pretty interesting. I never use it myself, in fact, but it has some benefits over JWT. Also, we have something called Biscuit, which is done by a French team, which is really interesting, in fact, and this is only for authentication and authorization of our microservices. There is some implementation, at least in Java. In PHP, we have something, but I don't know if it's released yet, and probably in Go and etc. This is kind of the best world over JWT and Macaroon. There is a lot of blog posts and so on, so maybe it could be interesting for you. And finally, there is something also interesting called Pazeto. The creator of Pazeto find the JWT too weak in terms of security, so he decided to write something better. And in fact, there is a PHP implementation, so this one, about Pazeto, which is working, and you can totally use it. But I think there is a draft RFC, but I think it won't never be a standard like JWT. So it's the end of this presentation. Let's try to summarize. So we saw that JWT is now something really is a standard of our industry. But like all the stuff we touch about authentication and authorization and so on, this should be implemented carefully. You should really think of JWT implementation as a real feature of your application, and so do not just rely on the first README part of any library. So choose well your algorithm, deal correctly with your keys, etc., etc. So thank you for attending this talk. Can you raise your hand if you learned something in this talk? Okay, thank you.